Hi everyone, thank you for coming to this talk. I know there's a lot of interesting stuff happening in the other room, but we'll record it all so you're not going to miss out. This talk is about module building in general, and half of it is theory and preaching, and the second half is actually showing off the code and just playing with some demos. So if you'll bear with me through the first part, the second part may be more entertaining. First, let me tell you a little bit about who I am. My name is Allen Rabinovich. I'm one of the front-end engineers on the YUI team. Just to sort of describe my background, I'm a computer scientist by training, but I've always been drawn into and by the usability side of computer science, kind of the more user-centric approach to designing software, and that over the many years that I've been doing this became sort of my interest and my specialty, and something that I always concentrate on. So when I work on a particular piece of software, I don't just think about making it a quality piece of engineering, but also concern myself with the user quality. So when I work on software, I think about how it solves the problems of users. Now, there's a unique challenge in building at a module level as a developer, because software libraries such as YUI have a special requirement, and that requirement is that they actually serve two distinct groups of users: the obvious end users who actually consume the applications that are built from our modules, and just as importantly, the developers who do the construction work. And so obviously this feature set that satisfies the needs of the two user groups is quite apparently very different, because they really approach modules from two different sides. But it so happens that the approaches for determining what the good features are and how to think about building good features, the approaches to doing that are in many ways similar. So this idea, the user comes first, is not really a new idea in software design. It's been growing in popularity. Then the idea of sort of the discipline of HCI as a subset of computer science concerns itself with that. But it does become much more complex when these two distinct groups of users are involved. So what I'd like to do is, using Calendar as a case study and kind of something that I specifically worked on very closely, I want to describe in fairly loose terms the process of designing and building YUI modules. Since the UI design pattern of Calendar, or as it is called by any other name, date picker, date selector, isn't really new and has been executed quite a few times before, there's a little bit of a difference, but it does not imply that there's no room for improvement. In fact, with the right approach and the concrete achievable goals which we set for the YUI3 calendar, a piece of software can always be made better. It can always be made more accessible to developers, more convenient for users, better optimized, and closer to being feature complete. I'd just like to point out that I prefer the name calendar to other names such as date picker and date selector, because during our explorations for what the functionality of the module should be, it turned out that calendar is the right name because the functionality of the module is actually pretty universal, and it doesn't just work for selecting dates, but also works for a variety of other purposes if it's built correctly. This is a screenshot for now of YUI3 calendar. Nothing special there. And so obviously, there are many other sources which have implemented it before. So these are just a few examples of the calendars that have already existed. Obviously, the YUI2 calendar that existed before, the jQuery date picker, a couple of other from other libraries. This one is gold-plated. I was very surprised. It's the default skin for that calendar. It was very interesting to me that somebody would make something like that. But so back to YUI calendar. There are four high-level goals that I believe every piece of software should hit when it's being constructed. The first goal is elegance. Now, the word generally is generally heard when it's applied to fashion. You know, people talk about dressing elegantly. But elegant style of software design, as I define it, is the process of essentially striving to do the intended tasks without overcomplicating them. And as kind of a side benefit of that, you get code that flexibly works for a variety of use cases that the developer could think of. And that principle is fairly broad, and it applies both to designing the API for developers to use and designing the end experience for the users. The second big goal is performance. Developers, and this is very important at a module level, because developers, when they build applications, very often won't pay attention to performance until it actually starts sort of dragging them down. And the reason that happens is all the modules they use drag it down a little bit at a time, and when everything in combination works together, it turns out that you get quite a sluggish application. So it is our big responsibility as module developers to hit performance as a big goal. The next goal for a good API that really is successful for developers is convention compliance. Now, this is not quite the same as standards compliance. What I'm talking specifically about are the conventions of the library that the developers love to use. So when a module is built to a particular library, be it YUI or jQuery or whatever it is, it really should be based on the existing conventions and the ideas that are well established in that library, because that will make it very familiar and very easy for the developer to build. And the last bit is really innovation. There's no really good point in building a module if it doesn't do something better or bigger or new that other modules before it were doing. And innovation comes in all sizes, big and small. And it's a really important criterion for really moving the software world forward. So what I'd like to do now is go through the stages of the design process specifically for the calendar and illustrate what it is we did for that module to build it as solidly as we could. And the first step in that process, and it's kind of a pretty obvious one, but a lot of people forego it and sort of start from scratch without really thinking about what came before them, is studying prior work. Now, with an existing module like calendar, prior work already obviously exists, but there are also new modules that are completely new and that don't really come with any specifically software experience associated with them. So what you would do in that case usually is really reach out to other areas of human endeavor and try to think of analogies and similar structures. And there's actually going to be a talk in the next hour, I believe, on the dial widget in YUI 3 built by YUIConf, which really doesn't have precedent in the kind of on-screen UI world. And so there are a lot of other precedents for it that you can think of, like the iPod scroll wheel or even the steering wheel of a car. And I think Jeff will use it in a few examples to demonstrate that. But so in our case, the body of work is not just existing, it's actually really vast, and it stretches far back beyond the world of software. And amazingly, if you were here for the talk, I think a couple hours earlier, somebody used exactly the same slide, and we did not conspire. This was completely accidental. So this is one of the earliest known calendars, obviously. It's the Mayan calendar. Now, of course, you don't just look at the prior work. What you do when you look at the prior work is a very specific exercise of pinpointing what is good and what is bad about it. Now, if I told you that this is prior work for YUI calendar, you would say, oh no, YUI calendar stops at 2012. And I would say, well, no, because that's not a strength of this calendar. The strength of this calendar is a beautiful rendering. The weakness of this calendar is the fact that it stops at 2012. And so that's something we should take into account when considering prior work like that. On a more pragmatic note, and sort of closer to the modern calendar usage, because really anything below 1684 doesn't actually apply, because that's when the British went and just changed the calendar completely. We looked at previous implementations of actual software calendars, and that provided us with a great deal of information. So, take the jQuery date picker, for example. What does it do well? Well, it has really good prepackaged internationalization that you can switch to any language in the pack instantly. It's really fast to get started with. It's just a few lines of code. How those lines of code are written, I have a lot of problems with, but it is a few lines of code, and you've got to give it to the module. And what are the weaknesses? Well, one weakness is it's kind of large, so there might be a lot of unoptimized code there. And if we actually were to dig down and look at the code, it looks like it heavily mixes markup in with logic. So any kind of restyling or remodeling the calendar, if you wanted to use a different template or a different structure, would be a nightmare, because basically every time you're dealing with this calendar, the logic is mixed right there and with a markup. So that's a little bit problematic, and that's something that we can take down as a weakness and note that that's something we really shouldn't do. The other calendar we looked in the course of this exploration is the YUI2 calendar. It's been written quite a few years ago, and it also has many strengths and weaknesses associated with it. So it has some really wonderful features like multi-pane rendering and multiple selections, so you can select ranges of dates. It'll custom render individual dates, so that's a great feature. But what's weak about this calendar, for example, is that it does things in a rather crazy fashion. So for example, it has separate custom renders for every type of a date. So for example, you would assign separate renders for weekdays or for month days and year days and so on. And when you actually, if I go back here for a second, when you create a multi-pane calendar, it's not actually the same module. You create a new module called calendar group, which unites multiple instances of calendar. So that's really inelegant, and that's something that we write down as a weakness. And so after we go through this exercise thoroughly of studying the prior work and pointing out strengths and weaknesses, we can move on to actually sort of taking the weakness list, reversing it, and saying, well, these are all the strengths that we should build into the new version of the calendar. So that's the other thing that the calendar, YUI2 calendar, does badly in terms of multi-pane calendars. So after we sort of looked at this large list of all of the features we saw in the prior work, we came up with a list of good things to build into the new calendar. And so this is the list of good things. So the basic UI should be there by default, multiple selection options, so you can select a single date or multiple dates, all kinds of events associated with dates, flexible layouts, ways to navigate the calendar that is not just month to month and so on, custom rendering obviously, and support for internationalization. So that, that's kind of the large big picture list, and it can obviously be written out in more detail and planned out much more, but it becomes a starting point in the design process. And that leads us to the next step. After you have this starting point and you have a list of features that you've built together from prior work, it's time to actually go and talk to the people who are going to be using those features. And in our case, the first user group are the developers. So we talk to developers. Now, again, in a situation where a module is completely new and it's the first of its kind on the market, you have to do something slightly different, which is generally go out and be a little bit of a salesman, right? Go and talk to people who are likely to use it, and then offer it to them and see how they would use it, and sort of feed off of those requirements. With a module that already exists, you can get much more concrete stories, and I want to describe just one such story, a particular property at Yahoo that we talked to that uses calendar, and they've been using a YUI2 calendar in the past, and that's Yahoo Fantasy Sports. And so what we did is we actually sat down with the developer, the lead developer for that particular portion of Fantasy Sports, and really talked through them through their scenario of usage. And this is the summary that we got, and I'll read it out loud. So the user is given a set of dates within a particular limited range, and they need to be able to select one or more of those dates. However, not all of the dates in the range are selectable, and some of the dates might require custom highlighting. So when you think about that description, and as you think about their scenario, right away you can start checking off individual features that are jumping out, right? So limited navigation range, clearly a feature. Enabling and disabling selection, another feature. Custom rendering of the dates, another feature. And so as we go through the different developer scenarios, and that wasn't the only developer that we've talked to in this course, we are able to really align the features that we came up with originally from prior work in terms of importance and detail them out a little bit more and figure out which parts of them need to be adjusted, modified, added to, deleted, and so on. So that really helps you hone down on a fine set of features that you would like to see in your module. Now, for each conversation like that, you really want to evaluate if the functionality you've planned in the first step is sufficient. And so one of the best ways to do it is to actually take the required scenario and then write some vaporware code for it. So not code that can be executed because nothing, no module has been written yet, but how you would imagine a module would be used to satisfy this particular requirement. So this is a bit of code that I produced when in response to that scenario. And it does something like it has two dates that limit the range of the calendar, so the starting date and the ending date. It has certain dates that you don't want to select and certain dates that you want to highlight. And it has some custom rendering function for highlighting specific dates. And then you would generate a configuration object that would instantiate a calendar with the some minimum and maximum date. You would tell it which dates you want disabled and which dates you want custom rendered and what the function that rendering them should be. So this is really kind of a first thought approach. Get the code on the page. Think about what's actually possible. Is it possible to do what is described in the scenario in the way you're thinking about it? And then you create a new calendar instance, and when a set of dates is selected, you'll probably get some selected dates back. Okay, so that's good, and that's a good place to start thinking about it. And I generate a lot of snippets of code like that. And this is really where you can start thinking about designing the API. So you look at this code and you look very carefully and you think about what about it is inelegant? What about it that can be simplified in terms of API and made more concise, more understandable to the developer, and more universal so that it gives the developer many more opportunities to do something differently. I'll actually jump out of here and, actually, before I do that, what we noticed, what I noticed instantly about this code is that the idea of custom rendering dates, highlighting individual dates, and disabling certain dates, they're very similar ideas, right? You're essentially applying a particular filter to dates based on a set of dates. And the way those dates are specified is a little bit odd, right? Because essentially in this little sketch, I'm just passing in a list of dates. What if there are 50 of them? That's a long list, right? What if there are 500 of them? What if you want to disable all dates except these 5, right? So that gets really hairy. And so those two pieces of functionality are similar, and they don't seem to be implemented in a good way. So what's a better way to implement it? And so what came out of that exercise, and I kind of want to highlight that's one part of making the design of the API more elegant, is the set of APIs for calendar called rules. And I'll show you how it works. So now we'll actually get to the code. So this is, by the way, the current version of the calendar. So this is kind of the very simple instantiation, and in some sense, that's just following the conventions of YUI and how widgets are instantiated. So you just give it a container, set the width, set the current date you want to set it to, some parameters, whether to show or hide the previous month, and then when you generate it, there's your calendar. So rules. How do rules work? For example, let's say you wanted to disable a particular set of dates. The easiest way to specify a set of dates is with a hierarchy. So basically a nested object where each level of the nesting is a larger and larger date scale. So at the top level we have years, at the next level we have months, at the next level we have days of the month, and the next level we have weekdays. And so at each level you can specify an arbitrary list. It's a mixed list of either ranges or individual elements. So for example, for 2000, for the year list you can say 2011, but you can also say 2011, 2012 through 2015. And that will cover all those years. And then within those years, it'll cover the month of November. 10 is November because the standard date offset is, the month offset rather, in JavaScript is starting with a 0. You can also use the keyword all when you want to cover all possible dates of the month, so in that particular case. And then, if you wanted to cover just Sunday and Saturday, you would specify 0 and 6. So what this disabled dates rule will match are Sundays and Saturdays on any date of the month in November of 2011 and Novembers in 2012 through 2015. And then all you have to do is pass the rule to my calendar. Basically, you're setting a custom render which includes a rule specification, and then just tell it that the rule for disabled dates, so every date that matches that rule that should be disabled, is disabled dates. So in fact, if we run this code, you'll notice that in November, the Sundays and Saturdays are disabled. So that's performing exactly as we expected to, and we, by the way, limited the range of the dates to through January of 2012. So what we'll do is we'll take that limit out, and I'll show you that the rule, because we modified it to also work for 2012 through 2015, also fires for the Novembers of those years. So November 2011, the dates are disabled, and then in the next November and so on up to through 2015. So this is a really versatile way to specify sets of dates, and it has a lot of flexibility in how the developer can do that. And as I was pointing out before, really specifying filters for dates, for disabled dates, is very similar to specifying just custom rendering for individual date cells. And so we can in fact do that. This is actually the wrong slide. I think I overwrote the slide that I wanted to show. Let me see if I can. Since that happens, I'll just code from scratch, because why not code live during a presentation? So what we can actually pass to the custom render is a custom filter function. So that's why this line of code might have seemed a little bit awkward. Like, why are we passing the rules object encapsulated in this custom render property? Well, the reason for that is custom render actually takes two parameters. The first one is rules, and the other parameter is called filter function. And so to the filter function, you can just pass a function. Oh, the tabbing is a little bit off. Let me just move it really quickly. You can just pass a function that takes 3 parameters, and this function is fired every time a date matches a particular rule. And so within that function, we can actually specify what to do with a particular date, what to do with a particular date cell if it matched a specific rule. So the rules are passed as an array of strings. If it matches more than one rule, you'll get a list of all the rules a particular date matches. So you can just say if this array contains a particular string. So let's say we'll create some custom rule in a second. So if that is greater than or equal to 0, let's just set the color of the node that the date is in to red. So we'll do that. And now let's create this custom rule separately. So let's say maybe every Monday in November. So you can specify it at the same level as you specified the disabled dates rule. So instead, it's just for Mondays. So every Monday in November should be red. So we'll call that, custom rule. And now if we run that, and we got all the curly braces matching. Every Monday in November, in fact, renders as red. So really, really easy to do custom rendering on specific nodes. One interesting thing I'd like to point out is how building these more complex modules actually drives the development of the infrastructure. So when I was constructing this, one interesting problem I encountered, and I'll talk a little bit about this in sort of when I discuss the performance, is that there's a lot of reuse that's happening in the nodes in the calendar. And it turns out that when I let the developer modify these nodes, I want them back when they switch to a different month. So right now, I do my own node. It's essentially like stashing. Like if you're familiar with Git, when you stash and then you change things. and then you pop and it's back to like it never happened. So that's basically what I'm doing. But the idea that we've had is that it would actually be really useful to build stashing into Node as a native behavior. So you can actually just go stash, do whatever you need to modify with the node, and then when time comes, you just bring it back exactly as it was. So that's an interesting additional behavior that will probably end up in the YUI node, which is a low-level infrastructure module. That's custom styles and custom rendering. And what's interesting is that this is a very elegant approach, but it doesn't actually cover all bases. This is where we stopped for YUI 3.4. Such was, the amount of time that we had. But it turns out that you can do better with the rules and improve them. And so this is actually something that we'll be putting in YUI 3.5. The idea is that this particular method is not well suited for specifying large ranges of dates that span multiple months and potentially multiple years. Because every time you cross a boundary of a month or a year, you have to essentially create a new setting for a rule. That's the very first thing. We'll actually add a data type to the top level of this rule hierarchy, which will allow us to specify just straight up ranges of dates without nesting down to specifics. And we'll also allow developers to specify the nth weekday of a month, which actually turns out to be a very common use case. People want to filter the calendar for the first Monday of the month. Every first Monday of the month, do something custom. So that's something that we'll also build in, and that's an additional syntax for that. Note that these syntaxes are built on top. They expand the rules API. They don't actually modify it. So there are no backwards compatibility issues. They just built on top of what already exists. All right. Another point of elegance that I wanted to highlight in Calendar is the fact that and this is part of the multi-pane rendering requirement that we built, that we put together from the prior work and the developer feedback, is the fact that Calendar is entirely built on templates. Now, these are still custom-based template, but the YUI, as you may have heard, is actually moving to handlebars for its template support. So we will rebuild Calendar on top of handlebar templates. But as it stands right now, Calendar is completely templatized from the lowest level of individual date cells to all the way to the grids and sets of grids. And let me show you how easy that is to use. Let me just switch back to the code view. The templates are just strings, and they're right now static properties of the calendar. And so you can modify the template by switching it out. The default template is a single pane calendar. So all you need to do is just replace the content template of calendar base, which is the rendering foundation of the calendar, with a two-pane template definition, which is right there. And if you run the code, voila, you've got a two-pane calendar. It's as easy as that. We also ship a three-pane calendar. So that requires a one line of code change, and you might want to increase its width because right now it's width limited, so make it bigger so it all fits, and you have a three-pane calendar. Now, what if you wanted to do something completely custom, like your own thing, maybe a full year worth of grid of months, right, for whatever reason, or even something more complicated. By the way, the more powerful, even more powerful part of it is that it doesn't even have to be a tabular layout of the calendar, right? You can imagine calendars that are just a list of individual dates with some custom content in certain date cells, so like a list of events or whatever that may be. And you can do that because you can modify the lower level templates, not just the top content level template, and actually rewrite the individual elements and make them, instead of the TDs and TRs that they are now, you can make them LI elements and UL and so on. So what if you wanted to do something more custom? Well, you just swap in your own template. It's as simple as that. So here I have a full year template, which actually uses YUI grids for layout. Grids already comes with Calendar because it uses it for its own pane layout. So you just get that for free. And it uses grids, and it has a few rows of individual thirds. And you'll notice that there's just a Calendar grid template token in each row. And so that's all it takes. You just specify this template. And then when you run it, you have a full grid, a full year grid of Calendar. Just as easy as that. Now, I hear potentially a question. Is there something potentially wrong with that? Maybe? Yeah, so it's unfortunate, right? Because it's a large grid that still has the first month's name on it. It turns out you want to account for that, and what we did is actually build in a custom render for the header. Let me do I have an example for that? No. Let me do just a little bit of a live coding here too and define a custom render for the header. The property is called header renderer, and so we can just do my calendar set header renderer function. It takes a function as obviously a parameter, and what that function gets is just an argument of the date of the first month that the calendar is displaying. The dates in the calendar are always normalized to the first of the month. So because it uses date as its basis, so when you set a date for the calendar, for whatever month it is to display, that date, whatever you set it to, will still get normalized to the first of the month that you specify. So we pass it, the current date is what the header renderer receives, and then it outputs the actual string that should be the header. By the way, you can also put just a date formatting string instead of a function. So it doesn't have to be a callback. You can just specify a date format. I think there's a standard ANSI format that we support for date formatting. But let's do this as a custom way because we want to show a range of dates. Let me close these before I forget. Okay, so what are we going to do in this function? Well, we'll actually use a helper method from YUI data type date, which allows you to take a date and convert it to a specific format string. So we'll say, just so that, because we'll use it a few times, and then let's compose the output string. So we'll say format the first month first. Let's say format, and we'll put a month and a year like that. So this is the ANSI formatting standard for date strings, and maybe add a dash between them, and then say a plus, and then let's output the last month, and we know there are 12 months here, so we'll do format, also the same format. Okay, oops. And we want to, obviously not the same date, we want to add a number of months to that date, and it turns out that our date utility has a method for doing that, so you'll just do date add months, ydate add months, current date, and we'll add 11 months to it. Okay, so that should do it. Close. Oh, and don't forget to return the output, because that's what we're actually generating. So let's see if I matched all my brackets again. Look at that. So just like that, you got the label that you wanted to see. And you can obviously do whatever you want with the header renderer in much more detail. So that allows you to modify the calendar flexibly as you build it out. Another point that I wanted to point out is that it also, as specified in the requirements, it supports multiple selection modes, and all it takes is just changing the selection mode property. So if you set selection mode to multiple, it's single by default, like that. But if you change it to multiple, it'll actually support using the Shift key and the Command key on Apple and Control key on Windows to select multiple dates instead of individual dates. Now, you may have noticed that it's a very large calendar. Like, it's a big grid, huge set of tables, and it's pretty snappy. It works really quickly. So this really brings us to the goal of performance, right? You really have to think about performance when you're building out modules, because the developers are unpredictable, and they'll probably do something really crazy and you want it to still work really quickly. And so I want to highlight one really cool performance technique that has to do with rendering the calendar. So when you think about rendering the calendar, you have, let's say you did some computation, you figured out what the first weekday of the month is, what the number of days in the month is, and what, in the particular country you're in, what the first day of the week is. Some it's Sunday, for some it's Monday. My week starts on a Thursday. But once you figured all that out, how would you actually do the rendering? Do people have any suggestions? Just the first thought that you had. Any ideas? Anybody? Well, you must have some ideas. You're thinking about it right now. You're just not telling me. So may I? Yeah, please.
Well, maybe I will render the calendar outside of the viewport.
So that's a good optimization strategy, and the suggestion was to render it outside of the viewport, and we certainly do that. But just in terms of assembling the calendar, what would you do? Would you just take sort of and compose the table one cell at a time, and then put it all together? Basically, you know that you're starting on a Tuesday, let's say, so you'll have the first two cells will be empty, and then the Tuesday will be the first, and so on. And so you would assemble all these dates. I'm just venturing a guess out here. That's the first thing that I thought of. You have it?
I would use maybe just string templates and put it all together and then just put it.
Okay, but you would still put it all together. And so let's say when you switch to the next month, you would re-render it from the template, from scratch, each individual date, right? I mean, that's really the first thought approach. So what I wanted to show you is a way to do it that's actually really, really much better for performance. And it's inspired by a physical object. This is a calendar designed by a really cool young designer, Luis Pabon. And you'll notice that the grid is actually really funky. It's got multiple repetitions of the same numbers in the calendar. And all you do is, we call it a sliding mask technique, is you take a subset of that grid, and a subset of that grid represents a particular month, with some modifications at the end. You just have to tinker with one or two endpoints to account for the number of days in a month. Because if you think about it, there's really only 7 possible month configurations, because a month can start on only one of 7 days of the week. Now, the reality is it's actually 28 possible ways, because there are 4 possible lengths of the month, right? 28, 29, 30, 31. But that becomes inelegant. Packing all 28 possibilities into a single data structure is pretty hard, but we can pack all 7 possibilities into a single data structure and then deal with it. So what we do is this. Here's this grid. And we put what we call a sliding mask on it, which essentially means is we just hide specific columns of the grid and only show certain columns. And then when we need to render the month that starts on a different day, all we do is we expose specific set of different columns, different 7 columns, and we hide the rest. So you move over, and now you have a month that starts on a Saturday. You move over again, now you have a month that starts on a Sunday. Do it again, month that starts on a Wednesday, and so on. So it turns out, instead of re-rendering the calendar from scratch every time, every single cell, this method produces much faster results, because all you need to do is just apply some CSS changes. Yes, you have a...
Is this accessible for, for accessibility?
So it depends on what hiding method you use, and we would use... Oh, I'm sorry, I should repeat the question. Is it accessible for accessibility? So right now, we haven't actually made calendar fully accessible. This is something we're still working on. But in principle, what happens to the columns that are hidden is they are set to display none. And the screen readers, to the best of my knowledge, ignore those elements. So structurally, it should still be perfectly accessible, yeah. There shouldn't be problems with that. But right now, the calendar doesn't have fully accessible markup, and that's definitely on our radar to implement in the future version. Yes?
How do you do February? If it's 28 or...
Right. So like I said, the question is, how would you do February if it's 28 days and so on? Is that every month might have a different length, but you just go in and you manually remove or add a few cells at the end. But that requires you to only structurally modify the DOM once or twice per grid as opposed to 31 times per grid. Yeah?
For the localization of month names and days of the week and so forth, would you consider mining data directly from CLDR and including that in the YUI distribution so I could just give a two-letter locale?
So we actually have, we've started that work. The question is, will we consider mining the internationalization data for calendar from CLDR and including it with the distribution? So the future versions of calendar will have all of the language packs in them and will include all that data. There just hasn't been time to implement all of them. Specifically challenging are the BiDi issues, where the languages where the calendar actually has to be rendered if in the other direction, which requires additional logic. Not actually in the calendar itself, because the table takes care of a lot of that, but in the navigation and so on. So right now we actually support Russian and Japanese, because those were the language packs that were easy for us to include. Japanese was contributed by an external developer, and I speak Russian, so I put in the Russian version myself. But other than that, we'll definitely build up to the full internationalization set. So that's the rendering optimization, and I actually wanted to show the internationalization next, so I'll just show you what we do have, and it's, oops, let me switch to here. There we go. So all it takes to specifically set the language in YUI is to pass the lang parameter. So if we pass Japanese, for example, oops, you get a Japanese calendar, and so that that takes care of the day of the week it starts on, and so on. So that's that will work, and it will work for all languages. We'll make sure of that. And we'd certainly welcome contributions. If you believe you can contribute a language pack or 10, I would love to accept that pull request. So that's internationalization. And one other quick thing I wanted to show you is that I guess we have about 15 minutes. So one thing I wanted to show you is that because calendar is a widget, it gets all of the cool widget magic that comes in YUI. So just to show you one example, it's really easy to make the calendar draggable. You just need to plug it with the drag plugin, because that's what we can do in YUI. So it's one line of code, right? I just do my calendar plug, and then I pass it the drag plugin. I restrict the dragging to a particular part of the calendar, which happens to be its header label. And now, just like that, the calendar is draggable by its header label. So this took one line of code to do that. And of course, all of the showing and hiding calendar is also really easy to do. So if we go on to the next example, here I have a couple of buttons, and I can hide the calendar and show the calendar. And notice that it fades in and out. Again, that's also one line of code. All I need to do is plug the calendar with the widget anim plugin, which automatically adds the fading behavior to the showing and hiding properties. If I were to comment this out, it'll just show and hide normally. So there's lots of really easy things you can do with widgets in YUI, and because calendar is a widget, it inherits all of that basically for free. Now, why is it a widget, right? Well, the reason it's a widget is after the API was designed and thought of, it had to be structured and organized, because the better you organize the API and the more you make sure it corresponds to the conventions of a specific library, the easier time developers will have building on top of it. And so, oops, let me go back to the presentation. This is I think that's actually an early architecture of the calendar. But just to give you sort of the idea of the thinking behind why things are organized in a certain way. So for example, calendar needs to perform a lot of date computations, right? Figure out the first day of the weekday of the month, number of days in a month. All of those methods actually live in a separate utility, because those methods are useful to more than just calendar, and really they don't just belong to calendar. And so there's the date math utility within the date data path. Calendar extends widget because that's really, a really solid base class for a lot of kind of medium level complex modules. You might consider stepping lower if your module is not quite as as complex as calendar, or you might consider go higher if you're building a whole application. And that's why I encourage you to go to the YApp talk by Eric, who will explain about this higher level infrastructure. So calendar base is where all the rendering logic goes, because if you think about it, a calendar at the beginning of the day is just a grid of numbers arranged in a particular way. So without any navigation or interaction, it's just a view. And so the rendering is the base level of the calendar. And then the module on top of that is calendar, which is the most common entry point for developers, and that has the selection and the interaction. Now, what's interesting about navigation is it's actually a replaceable piece of calendar, right? There are multiple ways to navigate in a calendar. You could go from month to month, or you could go between, you could have two sets of arrows, one for months, one for years. You could have a set of drop-downs on top, or you could even do something really funky like Vista-style calendar, which actually it nests in the calendar itself and shows you the view of a single month, or the view of a year, or the view of multiple years, a decade, a century, and so on. So there are all those ways to navigate calendar, and it turns out that because it's a swappable component, there's a really good infrastructure piece in YUI for that, and it's a plugin. Running a little bit ahead of myself here, the drop-down calendar navigator and the layered calendar navigator don't exist yet. We just have the basic calendar navigator, but it's really easy to build them. So you'll see them in the next release, or even sooner if one of you contributes them. See how I softly encourage you to do all my work for me? That's the plan all along. Making the calendar mobile by adding swiping gestures to it is also a plugin-like structure, as is making it a pop-up calendar. Although you saw that with the widget, with the widget tools, it's really, really easy to make a pop-up calendar even without really extending its functionality. So that's the architecture of the calendar, and a lot of work went into it, but we're continuing to build it and refine it and polish it, and we hope that it's a really solid module in the library, and it kind of demonstrates how modules should be built. And if you feel differently, you should tell me, because I'm really, really open to all kinds of constructive criticism. If we can make it better, we absolutely should. Okay, well, thank you very much. Thank you.